This is the first video for the particles topic. V1.1 is called Inside the Atom. So inside the atom, you're probably aware of this already, we've got protons and neutrons and electrons. And there are various ways of drawing that, but it's a fairly typical drawing. In the middle you can see a cluster of fairly large blobs. For some reason they're often coloured blue and red, but it doesn't specify which is which. Let's assume, for the sake of argument, that protons are red in this picture and neutrons are blue. Electrons are actually tiny things compared to protons and neutrons, so there's a little tiny dot there representing an electron, and somehow they're around the outside of the nucleus. So if we want to represent a particular atom, we use some sort of symbol. So it's either a single letter, like C for carbon or O for oxygen, or it can be two letters, like He for helium or Na for sodium. But there's an accepted shorthand for each element in the periodic table. And if we want to specify that atom a bit more carefully, we can write two numbers next to the letter, one at the top, one at the bottom. The one at the top is called the mass number, and the one at the bottom is called the atomic number. So what do they represent? The atomic number at the bottom represents the number of protons, and actually that's what defines the element you've got. So if you're not sure what the element is, all you've got to do is look up the atomic number in the periodic table, and that will give you the symbol for it and its name. At the top we've got the mass number, and that's actually equal to the number of protons plus the number of neutrons. So the number of neutrons isn't written specifically anywhere. If you want the number of neutrons, you have to take the mass number and subtract the atomic number, the proton number. Okay, so the A number, the mass number, is always bigger than the atomic number at the bottom. So that's something you need to make sure you know. Okay, if we have a think about the properties of protons, neutrons and electrons, so make this sort of table and make a note of their charge and their mass. So charge is measured in coulombs and mass is measured in kilograms. Now these are on the data sheet, so you don't have to remember them. The charge on a proton is plus 1.6 times 10 to the minus 19 coulombs. The electron is minus 1.6 times 10 to the minus 19 coulombs. So same number, just different signs. So in an uncharged atom, you've always got the same number of protons and electrons, and therefore the charge adds up to 0. It's only when you've got an ion, which has got an unbalanced number, that you've got a charge overall on the atom. Neutron has no charge. The mass of a proton is 1.6 times 10 to the minus 27 kilograms. Mass of the neutron is always also 1.67 times 10 to the minus 27 kilograms. If you do it to more significant figures than that, they are slightly different, but to 3 sig figs they're the same mass. The electron is 9.11 times 10 to the minus 31 kilograms, and you'll notice that there's a big difference between the power of 10 here. So minus 27 minus 31, that's a difference of 10 to the 4, which is 10,000. But that's slightly compensated for by the fact that this number is 9 and this number is 1.6. So actually the number is actually a couple of thousand. If you actually divide the mass of an electron by the mass of a proton, you get 1 over 1800. So mass of an electron is an 1800th of the mass of a proton, approximately a 2000th. Now, we can represent these atoms in different ways with these atomic numbers and mass numbers, and when we change the number of neutrons we get different isotopes. So the definition of an isotope, isotopes of an element, are they have the same number of protons, in other words the same element, but different numbers of neutrons. So for example, carbon in its normal form is carbon 12, so it has 6 protons. It also has 6 neutrons, making the mass number 12. Another form of carbon is carbon 14, that's the radioactive one that they use for carbon dating. So same number of protons because it's still carbon, but 14 is the mass number, so it's still got its 6 protons. The other 8 things in the nucleus must be neutrons. Another example, uranium-238, that's how you specify it, has got 92 protons. If you add the protons and neutrons together you get 238. Another form of uranium-236 has 2 fewer neutrons, but it's still 92 because it's uranium. So 3 words you need to understand and be able to use and know the difference between them. One is nucleus, another is nuclide, and the third one is nucleon, and they look and sound very similar. So what's the difference? The nucleus is just the name for the thing in the middle of an atom, made up of protons and neutrons, so it's a very general term. A nuclide is a particular nucleus. So we might talk about the nuclide of carbon 14, and that's got a particular number of protons and a particular number of neutrons. A nucleon is something in the nucleus, and basically the only 2 things that can be in the nucleus are protons or neutrons, so it's just the general term for one of those things. Okay, one of the things in the nucleus, proton or neutron.